Quick maths, let's try it again. And today we have a solve for x question. All right, so the first thing that I would love to do when I come across something like this is to actually take, you can decide. It's either you take this to the other side of the equation, or you can take this, but because there's a minus, I would love to take this one to the other side. Let's see how it goes. X plus 3 is equal to 2 root 5 minus x square both sides. Right, so we are going to have, oh, it has to be a square here, so we are going to have x squared plus 6x plus 9 is equal to 4 because 2 squared is actually 4, and now in this part the square root is actually going to cancel, because if putting a square is like saying square root multiplied by square root, so it will actually cancel. So we have ourselves something like this, 5 minus x. Right, so let's see, we have x squared plus 6x and then plus 9 is equal to 4 times 5 is actually 20, and minus 4x. So now like terms to one side, right? X squared plus 6x plus 4x plus 9 minus 20. Let's see if it works out, guys. Okay, this is gonna be plus 10x, and then 20 minus 9 is 11, so we're simply gonna say minus 11 is equal to 0. Now we factorize. Did I do the right thing? Oh yeah, I did the right thing. I just hope you can still see, guys. It's gonna be an x here and an x here equal to 0. Now we're looking for two numbers. These numbers, whenever you multiply them, they give you this number, but if you add them, they give you this middle term, right? So already I can tell that it's going to be 11 and 1, right? Because now the 11 has to take the sign of the middle term. We have spoken about that before. Our answers are actually going to be x is equal to 1 or x is equal to minus 11. Now whenever you have yourself something like this, I don't even know what it's called, you have to double check. You have to check which one is correct, because at the end you have to mention that one is correct and one is not. So you can actually check that by substituting your answers or your solutions to the original equation. Just if I substitute 1 to this equation, it gives me 0.